The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Separate Addition Processes and Using the Abacus for Reference. In the previous example, we opted for separate addition process and at the same time noted down the results at every stage separately. In this exercise, let us see how the abacus itself can be used for setting the results instead of noting down separately. Let us use the same example, 49.86 plus 75.356, and see how the addition can be done by treating the whole numbers and the decimal part separately. Though the separating bar has dots that are useful for doing problems dealing with the decimal numbers, there is no compulsion that setting of the numbers should be based only on the basis of the dots. If the child is able to keep in memory how many digits in the result should be earmarked for the decimal part, then the normal addition process may also be adopted. In the current problem, one option is to convert the decimal numbers into whole numbers. Thereby, we get the two numbers to be added as 49,860 and 75,356. Addition of such numbers is not complicated, but children may be comfortable dealing with the small numbers instead of doing problems with the numbers having more digits. In the first stage, we have to add 49 with 75. Let us consider this as a normal addition and therefore set 49 in the right extreme of the abacus. That is, placing 9 in the units column and 4 in the tens column. Let us set the number 75 at the left extreme of the abacus. Let us add 7 with 4. We can't do that, and therefore add 1 in the hundreds column and subtract 3 in the tens column. Now we have to add 5 with 9, which is not possible, and therefore add 1 in the tens column and clear 5 in the units column. Now we get the total as 124. With this, the addition of the whole number part is over. In the previous example, the child was asked to note down the results separately using a braille paper or with the embossed braille numbers. Now let us see how this 124 can be set in the abacus itself. Let us consider the first dot on the separating bar, and we know that the portion to the right of the dot indicates the decimal part and the left part indicates the whole number part. Let us set the 124 to the left of the separating dot. That is 4 in the thousands column, 2 in the 10,000s column and 1 in the 100,000s column. Let us get into the addition of the decimal parts. As there are 3 digits in the decimal part of the second number and 2 in the first number, we can convert both the numbers into whole numbers. That means we have to add 860 with 356. Now let us set 860 in the right extreme of the abacus. That is 8 in the hundreds column, 6 in the tens column and 0 in the units column. Let us set the number 356 in the extreme left of the abacus. Let us add the corresponding digits. That is, the number 3 should be added with 8. We can't do that, and therefore add 1 in the thousands column. We already have the whole number part there. For adding 1 in that column, we add 5 in the upper abacus and clear 4 in the lower abacus. Instead of adding 3, we have added 10, and therefore we have to subtract 7 in the hundreds column. In the next stage, we have to add 5 with the 6. We can't do that in the tens column, and therefore add 1 in the hundreds column and clear 5 in the tens column. Finally, we have to add 6 in the units column. Now we have the total value as 125,216 in the abacus, out of which the right 3 digits represent the decimal part, and the separating dot automatically separates the whole number and the decimal parts. Therefore, the result is 125.216. In the earlier example, there was a third stage when the added values of the whole numbers and the decimal numbers were further added to get the final result. But in this case, the addition of the decimal part happened with the whole number part itself. This is simply an option if the child is comfortable with, and therefore the decision of selecting a viable procedure must be left to the child.